Energy, conservation, and transformation. Energy is found and experienced in different forms. Two of these forms are kinetic energy and potential energy. Potential energy is the energy stored in something due to its position in space. Here, we see I'm on a bicycle on top of a hill. I have potential energy because I am on top, ready to go down. In the next video, we see a snowboarder on top of a hill. The snowboarder has potential energy, sitting on top of the snow. The basketball has potential energy before it has been let go of my hand. Another form of energy is kinetic energy, which is the energy of motion. When energy is stored as potential energy, it can be released through kinetic energy, as we see the cyclists move down the hill. The snowboarder's potential energy is transferred into kinetic energy as they slide downhill. And the basketball's potential energy is converted to kinetic energy as it's let go and falls to the ground. In science, the relationship between kinetic energy and potential energy can be understood as the law of the conservation of energy. This means that energy cannot be created or destroyed, only transferred into different states. To better understand this concept, we can make our own pendulum. We will need tape, a pencil, and a string with it tied on to a nut or some sort of other metal object. Next, take your pencil with 2 pieces of tape and tape it to something firm, like a desk, with about 1 inch sticking off the desk. Now take 2 pieces of tape and stick one to each end of your piece of paper. Next, attach your piece of paper to the bottom. Take a marker and make 2 marks about 6 inches up on the piece of paper, like this. Attach the end of the string that doesn't have the nut to your pencil, so your string is roughly 7 inches long. These marks will be our reference points for dropping our pendulum. Now, hold the bottom of your pendulum by the nut at one of your marks. Release the pendulum as straight as possible. Watching in slow motion, we can observe the laws of conservation. Notice how the weight returns to the same mark that we started with. So, with our understanding of the law of conservation, what other questions might we ask? If a car has kinetic energy, where did this energy come from? And what's the source of its potential energy? When we see leaves moving in a tree, we observe their kinetic movement. How is this energy transferred? And finally, when we see steam rising from a cup, we see the energy transfer of heat. I hope you learned something about conservation of energy and the transfer of energy. These interactions are happening all around us.